Today we're going to dive into option pricing. We know that an option and its replicating portfolio must have identical values. Otherwise, arbitrage profits can be earned by longing the undervalued instrument and shorting the overvalued one. Let's jump into a practical example. Here, we're given the current price of the stock and two possible prices 1 year later, S up and S down. Let P denote the risk-neutral probability that the stock price rises. Here's the P, the risk-neutral probability that the stock price rises. And 1 minus P denote the probability that the stock price falls. We solve for P under the risk-neutral pricing framework. Here, imagine the stock will generate RF for the period. And let's get the equation solved. The P equals to 0.7. Then we can calculate the expected price of the put option 1 year later. And the present value of the put option by discounting. And the present value of the put option is solved to be 5.71, lower than its market price. Here is the market price of the put option. So there is an opportunity for arbitrage. To find the theoretical no arbitrage value of this put option, we need to calculate the replicating portfolio value and construct the replicating portfolio. When it comes to replicating, the most common way is put call parity. And here, we do not have the call option price here. And we cannot use the put call parity. So we construct the replicating portfolio by the stock itself and risk-free bound. So let A be the number of shares of the stock and B be the market price of the risk-free bound. Here, A or B can be positive or negative. When it's positive, it means long position. Otherwise, it means short position. The value of the replicating portfolio, if the stock price goes up, is like this. A times the price going up plus B times 1 plus RF. Similarly, if the stock price goes down, the value of the replicating portfolio equals to A times the price of going down plus B times the risk-free rate return. Okay. And the replicating portfolio should generate equal value as the original put option here. The original put option here, 0 or 20. Two possibilities. 0 or 20, and corresponding the replicating portfolio here. Solving this system yields A and B. We can see that A is negative, meaning we need to short the stock, and B positive, meaning we need to long the risk-free bond. Here is the result. Short position in stock and long position in risk-free bond. Let's take a look at the arbitrage strategy. Since the theoretical value we calculated in part A is $5.71, and the market price of the put option is $9.5, and the market price is much higher, and there is an arbitrage opportunity, and the put option is overvalued because it's higher. And the step-by-step arbitrage instructions are here. To exploit, the arbitrager should sell high and buy low. And what is high? The market price itself, the put option itself is high. And what is low? What is low? The replicating portfolio is low. Why? Because the replicating portfolio equals to the value of the theoretical, the value of the put option theoretically. So we need to buy the cheaper replicating portfolio and sell the overpriced option. At time t equals to 0, time 0, we need to sell or write the put option and receive its premium, and buy the replicating portfolio. The replicating portfolio has two subparts. Subpart 1 is shorting shares of stock. Here is the subpart. The replicating portfolio has two subparts. The first subpart is shorting the shares because A is negative. So here is short position. And long B risk-free bond value B. So the replicating portfolio itself has two parts. So the arbitrage opportunity needs to buy the replicating portfolio, and it equals to short stock and long or invest in the risk-free bond. And by shorting the stock, we can receive US dollars. And by investing or longing the risk-free bond, we need to pay B US dollars. And the net initial cash flow equals to the first part, sell the high here, and buy the low. Here is the low. Buy the low has two subparts. The first subpart is here, and the second subpart is here. So the net initial cash flow is positive 3.79 US dollars. And at time one, i.e. the expiration, we need to close positions of both selling the put and buying the replicating portfolio. Why? Because at time zero, we sell the put option. So at time one, we need to close it, close it, close it. Uh, here, close it. Sold, expire. The option you sold expires worthless if the stock price goes up, and the put option is worthless. We owe nothing because the counterparty of the put option will not exercise. And we need to buy back the stock. Why? Because at time zero, we short sold shares of stock, 0.6667 shares of stock. And we need to buy back finally. And we got pay. We've got to pay. And it's an outflow. And lastly, we need to collect the risk-free bond reinvestment with interest. Here is the principal and interest. So the net cash flow at time one is zero. And when the price goes down, here is price the scenario that the stock goes up. And here is the scenario the stock goes down. If the stock goes down, the option buyer, the counterparty, will exercise the put option against you. You must buy the stock and loss and resulting a loss here. And similarly, you need to buy back the shares to cover your short selling at time zero, and it's an outflow. And finally, you need to collect your risk-free bond, both interest and principal. So the net cash flow at time one is also zero. So in both scenarios, your future obligations perfectly cancel out, leaving you with the initial $3.79 profit. Here's the initial one, the initial cash flow here. So the profit is 3.79 US dollars. For the next question, why it's not realistic to implement this arbitrage strategy in real world? There are several reasons why you can't do this. First, transaction cost. Second, short selling constraint, because short selling requires borrowing it first. Stock borrowing fee can be high, and in some cases, hard to borrow stocks. You may not be able to short the stock at all. Further, you face the risk of short squeeze or having your borrowed shares called back early, the so-called call option, callable stock. And the third reason is that the interest rates of borrowing and the lending can be different. And the last, the fourth reason is that the market frictions and the execution risk. And the last reason is model risk, because the one period binomial model is a massive simplifications. It assumes only two possible futures prices and a constant volatility. Real markets have continuous price movement. So what if we replace the put option with a call option? The only difference, the only difference is the A and B, because in the put option scenario, the A is negative. The A is negative. A is negative, and B is positive. But in the call option scenario, A might be positive and B might be negative. And here we have a summary of how to construct a replicating portfolio. First, put call parity. Second, delta and gamma hedging. Delta and gamma hedging involves um, Taylor expansion. Delta depicts the linear change of the option price to the stock price, and gamma is the second order change. The last way to construct a replicating portfolio is using futures or forwards when there